We are live. You can start.
You can start now. Thank you. Thank you. Welcome all Department of Fisheries officials. As you know, the Andaman Nicobar administration is celebrating State Learning Week from 18/3/2025 to 21st/3/2025, and there are 15 courses, different courses listed for attending by the officials of Department of Fisheries, wherein we have a domain course. The Department of Fisheries is having a domain course, and as requested, a topic was selected: investing in quality informed management and thriving communities. Today we have a speaker. We have a speaker from ICAR-CMFRI, Dr. K.G. Mini. We welcome you, madam, to the session. And this session, especially this session, what we are targeting is to understand the data collection methodologies adopted in the fishery sector. And as our staff knows, we are conducting a data collection project in association with CMFRI. And it is the second year of the project. And what we are doing is we are collecting data, fish catch data from across the islands, landing centers, and with the technical support of ICAR-CMFRI, we are analyzing it for projecting yearly annual production and the potential also. So this session will be helpful for all the enumerators and technical staff for better understanding of data collection, analysis, interpretation, etc. So I request all the attendees to be very attentive to the session, and madam will be explaining all the basic information regarding data collection and how we can better collect the data, how better we can make our data, especially fish catch, then our gears, then the gear data, then planting data, everything. So I request madam to start the session.
Okay. Thank you, Sunasnas, for the introduction. So let us talk on the investing in quality informed management and thriving communities. So let me share the presentation with you all. I think the slides are visible to all.
Yes, ma'am.
Thank you. So in this today's presentation, I would just give an outline on the role of quality scientific marine fish catch data in fisheries management, which is the foundation for sustainable fisheries management, and why we have to keep the quality of scientific marine fish catch data, which is non-negotiable, and the different various methods of collecting marine fish catch data, and how this raw data can be converted into meaningful insights. I will be just briefly talking about the processing and analysis of the data, and coming out with analyzed results, how we can build a blueprint of towards fish stock assessment models. And after building the models, how we can translate the science into action, like how we can do the fisheries management. And we'll just conclude with some way forward towards the thriving communities, which we want to give it to them. So let me come into as we all know that the importance of marine fishery resources, which is not just a source of food. Actually, it gives the economic benefits, as you all know, and livelihood for the coastal communities, and it's foundation for many other industries, and it has got a huge potential also. But at the same time, the challenges like overfishing and environmental degradation, it threatens their future. So how to look into these challenges? So let us have a look at the marine fishery resources. As we all know that unlike the land-based resources, the fish production in the sea is dependent upon the productivity of the sea, the availability of fish at a given point of time, the fishing effort expended, and accessibility and vulnerability of the resources, and a number of other factors. And moreover, just like unlike the land-based resources, it is not static in nature. It is frequently migrating, and it is invisible. So it makes this particular resource, it makes it so unique and complex. It is very difficult to monitor, manage, and intervene. So whenever we look into the quality data, the complexity of fisheries management is so unique in nature. We have to put a lot of effort into the getting scientific data on this marine fishery resource. So as I mentioned, the quality in which, because the catch data, which is, as you know, it is a vital science of the fish population. Whatever has been taken out from the sea, that is only thing which we can see. So that is how much fish has been removed, which species has been targeted, or which species has been removed, how much effort has been expended to take the fish from the sea. So these are such an important, because whenever we look into a particular species, many questions should come into our mind while collecting the data. Suppose when one particular fish is caught from a particular gear, many things we have to infer from seeing only that particular fish, because which depth it was living, the different types of which all species were interacting with it, and many things are there which should come in our mind, so that it should lead to a collection of a quality scientific data. So foundation of fish stock assessment, as we know, the catch rates, fish age and growth, environmental conditions, population dynamics, these are the different angles or different dimensions of the data which we have to collect and analyze. There are different types of methods for marine fish catch data collection. As you all know, that is, I'm just talking about in a worldwide scenario perspective, like onboard observer programs are there, which most of the developed countries are doing, and landing center observers that we are doing, like India, and you are a part of it. And self-reporting by fishermen are there, that is logbook-based reporting, and a combination of these different methods. So earlier, historically, we were depending on the onboard observer, landing center based observers, and self-reporting, etc. But in the modern era of technology, the world is moving towards electronic monitoring systems with onboard cameras and sensors, which provide a comprehensive data on catches and bycatch. And there are now vessel monitoring systems are there, which uses satellite technology to track fishing vessel locations, because the fishing location is such an important thing, that the geolocated where are the fishing grounds, whether whether the fishing will affect their spawning grounds. Many things has to be derived, can be derived using this particular data set by collecting using VMS. And electronic reporting is there now. Digital gadgets are available, so that we can whoever is collecting the data, they can use the digital devices, and they can report it electronically, and it saves a lot of time, money, and that is the most important thing at right present now. And moreover, even citizen science, which is a very emerging area towards collection of marine fishery resources data. And now coming to, because these are fishery dependent surveys like onboard and landing center and self-reporting or logbook based reporting by fishermen or whoever. It's all fishing dependent surveys. Now let us look into fishery independent surveys, because science is always looking into unbiased way of doing things, or unbiased data, or unbiased estimates. So usually acoustic surveys are there, where scientists utilize sonar technology to estimate the fish populations, and tagging studies are there, like even egg and larvae studies and tagging studies are there, egg and larvae studies are there. So, and in this particular area also, this fishery independent service, it's a very highly expensive affair as far as India is concerned. We may not be able to afford the fishery independent service. We are doing it, but it's a very highly money. A lot of expenditure is, or a lot of money has to be there to conduct this type of service. And these surveys are also, they are also constantly evolving nowadays with smartphones, onboard video, electronic logbooks, and even machine vision is there. So these are promising tools for efficient and accurate data collection. Now, let us look into our country, how we are doing it, as most of you are aware of it. But just to give a brief or to refresh what we are doing and how we can improve our monitoring and assessment of marine fishery resources. Just I'll go through the existing methodology that is followed by our country, and we'll look into some of the fishery stock assess models which we apply here using the catch and effort data. So as far as India is concerned, the Central Marine Fisheries Research Institute, which is mandated to do the monitoring and assessment of marine fishery resources in India. And the more complex factor as far as our country is concerned, it is the multi-species, multiple gears, multi-seasonal fishery, which is again making the data collection more complex and unique. And as we all know that the essential requirements for assessing the exploited stock is our catch, fishing catch, the effort expended, the biological aspects, and definitely the socio-economic aspects. These are also, we need all these things to get a comprehensive assessment of the stock. This is about our statistic actually. According to 2016 Marine Fisheries Census, we have around 3.99 million fishermen population in India, and with around 8.64 lakh fishermen families, which are totally depending on the marine fisheries. And around 1,269 landing centers are in our coastline. So as far as you know, 1,269 landing centers means it's not easy, or it is not at all practical to do a complete enumeration of the landings which are occurring in the landing centers. So in India, as we all know, fish landings takes place all along the coastline, day and night, throughout the year. So the only option which we have is the sampling procedure, and not only that, a scientifically valid sampling scheme that is the only feasible way in front of us for estimating the fish landings and fishing effort. So since inception of Central Marine Fisheries Research Institute in 1947, it has initiated the process of collection of data on marine fish catch, effort, and biological parameters. Several pilot surveys were conducted along the Malabar coast by Indian Agricultural Statistics Research Institute and along with the Central Marine Fisheries Research Institute, and came out with a particular 3-stage stratified sampling. And a lot of modification has been done. And in 1959, we have came up with a stratified multi-stage sampling design, and it was implemented along the entire coast in 1961. So currently, we are using a stratified multi-stage random sampling design, wherein stratification being done over space and time. You could see there are 3 keywords in this particular sampling technique. One is a stratified, another one is a multi-stage, the third one is a random. So stratified means, why do we want to do a stratification? Means grouping a homogeneous units together, so that in a particular stratum, the elements or the items, or they will be homogeneous in nature. And second stage, multi-stages, we are doing the sampling in different stages. So first stage we will be selecting some samples. Second stage, another set of samples. Likewise, it goes on. And randomness. Randomness is the most important concept in statistics, wherein we can avoid the bias in the estimates. So in our methodology is it's a stratified multi-stage random sampling design, wherein stratification is done over space and time. So as you all know, in today, whenever we talk about something, we cannot talk anything without space and time, without tagging the spatial point and the time point. So similarly, whenever we talk about landings, it has to be tagged to a space and it has to be tagged to a time, which particular time it has landed and in which place it has landed. So in 2 dimensions, the stratification is done. And further, throughout the coastline, it has been divided into different zones. It is termed as fishing zones. You may be knowing that. A fishing zone is actually, it's a combination of landing centers, which are geographically nearby. And when you add the fishing zones together, you will get a maritime state. And when you add the maritime state, you will get the region. And when you add the regions, you will get the all India estimates. This is how the estimates comes out from this particular sampling design. And when we talk about the time dimension, the basic unit is a month. And when we add the months, we'll come out with an year estimate. So at present, the CMFRI sampling methodology is followed in 9 maritime states and 2 union territories, along with the Andaman Nicobar Islands. So this is excluding Andaman Nicobar Islands, actually the total number of landing centers and the number of fishing zones in each maritime state. And as you all know that we have conducted a pilot study in Andaman Nicobar in 2022, and the collection system is placed in 2023. And in your case, there are 24 marine zones, which altogether consist of 70 landing centers. This is the distribution of landing centers in your setup. You can understand better when you see the distribution of landing centers. So whenever I talk about the stratification, you can see here, and these are the fishing zones. So fishing zones, in a particular fishing zone, 4 landing centers are there. That means that 4 landing centers are somewhat homogeneous in nature. In 3rd fishing zone, Andaman 3, South Andaman, there are 6 landing centers. So you can see 6 landing centers which are homogeneous in nature. But sometimes what happens is, out of the 6, maybe 2 may be having more intensity or high intensity of landings and compared to the 4. In that case, you are supposed to stratify again to reduce the variability in our estimate. I'll be coming to that in the following slides. So just want to, because when I set 6 landing centers, in that, if suppose 2 are major centers, again you have to stratify it into a stratum 1, then other centers will be a minor stratum, so that the variability in the estimating can be reduced. So you can see here the number of landing centers. It is again the stratification is done with there should be criteria to stratify, isn't it? So the criteria is the variation in fishing intensity, the different types of craft and fishing methods. Suppose in a particular landing center only trawlers are operating, or otherwise gillnetters are operating, then it should be coming in a particular stratum. And also based on the number of boats or number of fishing units which come and land there. Suppose 100 are there, and another center with a 10, That means the 10 that should be considered as a minor, the other one should be considered as a major. So that you should give due weightage to the quantity of the landings and the quantity of the fishing operations which happens in a particular landing center. I think the concept is clear to you about the fishing zone and the stratification over space. Now we have fixed the space, that is the landing centers. Now coming to as I told you in the initial slide, we are using a stratified multi-stage. Multi-stage means there are different stages are there. So the first stage in statistically terms as primary stage units. So how to do a primary stage unit, that will be explained this particular slide. So going towards the primary stage unit, now we know what are the landing centers are with us. Now I have already mentioned you in the time dimension. Time dimension, month is the basic unit. So a particular month, suppose it is 30 days in a particular month. This is how we divide a 10-day period into 3 groups. And suppose you are supposed to select a number in random. Suppose 4 is the number which we have selected random. 6 consecutive days will be selected from the 10-day period. Likewise, it's termed as a systematic sampling. Those who are familiar with statistics may be knowing it. So you don't have to get into this thing. Only thing is how the distribution of the landings or the collection distribution is distribution over a particular month. See, suppose we are doing going to landing centers on the till 15th of the particular month. The other 15 days, what is happening, that will be missed out. So you need to have a uniform distribution of different when you categorize a particular month into different. So the distribution over the period is considered by following this particular procedure. So now coming to now we have around you can see 18 days are selected by this particular systematic sampling. 18 days are in hand. Now you can see different colors are given. So 4 and 5 is in a different color, 6 and 7 like that. So what happens is the 2 days are clubbed into one, and we make it into 9 cluster days. 9 cluster days, and these 9 cluster days will be taken. That will be in one hand. Another hand, we have the number of landing centers. So we make a combination of the landing center end day, and the person who is supposed to go to the landing center has been allotted to that particular day. That is, suppose as you see, there are 9 clusters of 2 days each. So 9 centers. So the person will be going to, or persons will be going to this 9 clusters of 2 days, and we have 9 centers in another hand. So we'll be allocating these 9 centers into these 9 cluster 2 days, and the person will be going to. That is why I told you the spatio-temporal. The space is fixed, the day is fixed, and person will be going to that center on that particular day. So in 9 landing center days will be observed. And when a person is going to that cluster day, again duration is given. That is it is being divided into 3 periods. So that sum of 3 periods contribute the data for a landing center day. That is 12 to 18 hours, 6 to 12 hours in the second day. And the night period, we usually inquire and get the information. And in India right now, there are many centers where night landings occur. In that particular case, we won't be able to follow this particular this fashion. So they will be given another way of another period of observation, so that the 24-hour period is covered by doing so. So as I told you, multi-stages. There are primary stage unit, that is a first stage unit. So it is a combination of landing center and day. I think you got an idea of how a primary stage is, how it has been formed. It is a combination of a space and time. Space is a particular landing center, and the day is the day which we have randomly selected from a particular month. Now, the second stage. Now we have reached that particular landing center on that particular day. So what we see is this. When I talk, I'm talking on behalf of the landings occur throughout the coastline of India. There are very big harbors where more than 300 or 400 or 500 fishing units land their catch. So it is not practical to record the catches of all fishing units landed. Again, there also the sampling of the units become essential. So there is a criteria which we usually follow to the selection of the fishing units. Suppose the number of fishing units is less than or equal to 15, you are supposed to enumerate all 100%. That is, 15 units has to be made. The observation from the 15 units has to be taken. And if it is more than that, this is the criteria which we usually follow. And apart from that, there are different types of gears are also landed. Like in a particular landing center, suppose trawls are landed, trawl, even gillnets are there, persines are there. That time, when you look into only 15, again you are supposed to get a representation of the different types of fishing units landed. Suppose 5 trawlers, you are supposed to take observation on 5 trawlers. Maybe again depending on the total number of catch landed, minimum number of persines, minimum number of gillnets, so that the representation of the fishing units are covered. Now, after selecting the fishing boat, the person has to record the fish landings. In that, that is whatever has been caught. There is again in that stage there is no sampling at all. After selecting the fishing boat, he or she has to collect the complete enumeration of that particular fishing boat. In the sense, the species-wise catch, the fishing effort expended, which gear was operated in that particular trip, which was the ground, the other details, the price details, everything has to be recorded by the person. So whenever we talk about the species-wise catch, the species identification is the most challenging one. Usually we give training and workshops to the field observers so that they should identify the species correctly. And recently we have launched a project to develop a highly, that means we also look forward for an automatic way of to get a fish identified automated. So using AI. So a project has been recently launched by CMFRI. It is an app is developed in this particular under this particular project. Its name is Marling at CMFRI. Therein you can upload the images from your landing center whenever you go. You are supposed to take the photographs and upload into this particular Marlin, so that we can make we are planning to make a software which will help us to identify the species correctly. It needs lakhs and lakhs of images so that the identification is to make the identification procedure correct. So it is in a process. I think you all are aware of it. Now I have already mentioned about briefly only the sampling methodology in the sense of it's a practical, how theoretical it is. Now, when we get into the planning of implementation of a sampling methodology, lot of planning is required. So as you all know that CMFRI is having its regional or centers and stations at 11 places, and we have exclusive field centers for data collection. Around 17 field centers are there. So every month the work schedules are prepared from headquarters CMFRI. That particular work schedule is the key, that is a initial or beginning point for a survey. In that it mentioned who will be going to when and where. That is a 3 key points which is there in the work program. So the person who is going to for the work in the next month, he gets the program in the previous month itself, on which date he is supposed to go to which center. So as you all know, because earlier CMFRI was collecting the data based on pen and paper based method was used, and it was time consuming. So when as the technology was advancing, we also moved into a web-based application software. This termed as fish catch survey and analysis, which was implemented in 2018. It uses electronic tablets and centralized processing and through a database server. So in that process, FCSA is doing 3 processes. Actually, first one is the data collection, second one is the analysis, third one is the report generation. As far as its design and deployment is concerned, it consists of different segments like online data entry using tablets. It allows multi-level user systems. It is composed of 2 types of front-end and 1 back-end. Back-end is the database server. And the front-end, as you all know, it runs on the tablet or the smartphone as a mobile client. This is just a schematic sketch of how it works. You can see the server there, and data analyst will prepare the work program and it will be uploaded in the server. And the fishery, the person who is in the field, he can access the work program in the tablet or mobile phone. And after collecting the data, survey data, the person will be uploading it to the server. And again, the analyst will be doing the validation, estimation, analysis, and report generation. This is the FCSA client on the tablet or mobile. That is mainly used by the field observers. He or she can log in using the login page. With you have been given an authenticated user name, user ID, and password. And you can fetch the work program, and these are the details of how it works, and all survey data. It just got different parts and all. I'm not going into details of that. So this is the version 1, the front end, how it looked like. You are supposed to log in and use your enter your password and login button like that, and you have to fetch the work program. And you can see the landing centers on that particular date and that particular period. After uploading the data, you are supposed to sync it so that it should sync to the server. These are the screenshot of the different screens which appears in the tab. So actually, as I mentioned, in 2018, CSA 1 was introduced. At that time, we have 2 IBM servers, and our database was Oracle. And we used Node.js for server side, and these are technology side, software, hardware, things which we used at that period of time. And client side, at that time, we were using the Samsung tablets, browser-based web application. So actually, it was a bit costly affair as far as whenever we collaborate with any other agencies, a procurement of another digital device for collection that is bit taxing for the collaborating uh, agency or so we just looked into another option that came out with FCSA version 2, which you all are using right now. The specification of its hardware, software, programming language is given here. This time what happened with this Oracle was again expensive, so we moved into open sources of Postgres, SQL, Alma, Linux, and more importantly, what happened is we changed into the Android 10 or higher mobile app deployment, because we moved so that we can use smartphones to collect the data. So version 2 has the key features which has enhanced the field customization, real-time input validation, many different validation queries we put into the version 2. So it has got more modular structure and more functionalities are there as far as version 2 is concerned. This is how the login page appears. You all know that, and you can see now we can track online because it's a dynamic system, and again GPS enabled, so we can see the real-time monitoring of the. This is also possible right now. So this particular work is published in a journal. Now I have talked a lot about how the data is collected and how it is being processed. So while processing, a lot of things has to be taken into because cleaning has to be done, some validation is to be done, so that the accuracy and standardization is possible. That too, we have different fisheries in different states and regions, and we come out with different level estimates, that is from species level estimates to district level fishing zone wise estimates, district wise, state wise, and then we pool everything and we come out with an entire country's estimate. So recently, just a few days, 2-3 days back, we released our 2024 estimates. This year around 3.47 million tons, and this is the contribution by the mechanized sector. As always, it contributes the maximum with motorized sector 23% and a meager amount of 1% by the non-motorized sector. As we always know that pelagic resources which dominate in our Indian seas, we get 54% is contributed by the pelagic. And you can see the major resources in the mackerel, oil sardine, ribbon fishes. This is as far as the country, the major resources landed in 2024. So we usually publish after releasing the estimates. We usually come out with these publications every year. So now we have a National Marine Fisheries Data Center. We actually, the data center, which is the custodian of all the data sets, where we have the sector-wise data, the resource-wise data. Resource again, the phylogenetic way that way the database is arranged. The sector-wise, month-wise. This is a different angles of the data which we have in an MFDC. Now, as we all know, there are a lot of challenges in data collection. That is, underreporting is the variability in fishing practices, environment of many different angles of the different angles are there when we address the challenges in data collection. So let me talk about very briefly on how a catch can be an underestimate, how it can be overestimated. Again, I have taken data from your own data set on mackerel. Suppose a particular boat, actual data is 600 by a unit. Suppose a person is reporting it as 400. You can see here the difference between The actual figure and 400, the estimated figure is 1,520 for on that particular center on that particular day. But we are supposed, we know that if there are 25 fishing days, it will be raised into 25 days. So 38,000 kilos of that is underestimated. Similarly, if you suppose a person is reporting it in a higher end, again 50, you can see here if it is reported as 900, but when we estimate it, the escalation in the rate, that is you can see the seriousness of reporting, how seriously we are supposed to report the data. Similarly, in terms of actual fishing hours, suppose the actual fishing hours is 60. If you are reporting is at 50, what will happen? If you are estimating it is 88, so you can see the whatever fish has been removed by expending this particular actual fishing hours, how wrongly we are reaching into. These are having when we do the modeling exercises, this have a lot of negative impacts. This is again the catch per hour of its estimation. Now, I have already talked about the challenges in data collection. Let me go a bit faster because only 10 more minutes left for me. So there are these are the factors because of the shortage of the trained personnel, infrastructure facilities, shortage of that, and data gaps is the resource limitation. Everything is a challenge as far as data collection is concerned. And the solution is again you see the collaboration. That's what we are doing right now. Now we came out with estimates. So let us build a blueprint by stock assessment models. Different types of models are there, from simple data limited models to complex age-structured and integrated models. Actually, the catch data is the fundamental input for all of them. So when we talk about the stock, there are a lot of questions can be addressed by stock assessment. What is the current status of a fish? How much can fishermen catch while maintaining a healthy and sustainable fish stock? So this leads to predictions. If a stock is depleted, what steps must be taken to rebuild it to healthy, abundant levels? So that leads to management advisories. So there are the foundation is single species models. You may be wondering that because you are in government agency which are mainly doing the administrative things and management things, but why should we know more about this? Maybe the question may come in mind, but the thing is, these are not directly going to. We are not going to directly apply these things in hand. But what is the data required for all these things is because you must understand when we collect the catch statistics, these are going the raw material to building the models. That is what ultimately we want. So you all know, you must have a foundation on the fish stock assessments, which are presently using and which will be maybe using in the future as well, as far as Andaman is concerned. So there are broadly it can be divided into two macro-analytical models and micro-analytical models. And as I told, the catch data, abundance, biology data that's a requirement. And whenever we talk about macro-analytical models, this is the basic equation everyone should always have in mind because we talk about the biomass at present. Biomass at present, it's a function of biomass of the previous period with the addition of recruitment and growth and with subtraction of natural mortality and the catch. Because when you see the sea here, we all talk about the sea at present. I have been initially onwards, I've been talking only about the catch. How important this catch is, because we are removing a portion of the biomass by catching the fish. So natural mortality is not in the hands of human being. That happens in the nature. This sea is the only thing which we, a human person who is in, it's only the human intervention or interference in the nature and removing a portion of the biomass by catching the fish. And all the models are, the ultimate goal of each and every model is to estimate the particular catch sea. So the sea is the most important. If the nature can actually, we don't have to talk about anything about the models and all. If we are not removing any fish from the sea, if because we are removing a portion of its biomass, then what happens? That is the question we all look into. So again, that's about the macro. When we talk about micro, that is, we are going again into depth, like age-based models, length-based models, growth equation, length-based relationship, catch equation, mortality. So there are many, what do you say, down to when we talk about the virtual population analysis, the number of methods are in the micro level. Single species, the limitation of single species is actually we usually use a particular species, we'll focus upon, we talk about its catch, its life history and its value, and that's it. But we don't talk anything about its habitat characters, where it wants to live, what is the interaction with that particular species with the nature, and how it, those things are not at all considered in a single species model. That is its limitation as well. So expanding our view into a multi-species model, like we all know that no fish stock live alone. Then this is the most important view which we should look into. So multi-species models, it takes takes account of technical interactions and biological interactions, and it gives us an improved estimates of natural mortality and recruitment. It gives us a better understanding of spawner-recruit relationships, variability in growth rates, and different biological reference points which we are looking into. A fishery manager is always looking into biological reference points. So in a broad-based, the ecosystem-based models, that is the most suitable model which everyone should follow. But at the same time, it demands a lot of information to model a particular ecosystem model. We are supposed to give a fishing pressure data on fishing pressure, species. It takes everything into account: species interactions, food web, profit dynamics, environmental changes, nutrient loadings, everything into consideration. These are the different advanced models many developed nations are applying in their waters, EcoPath, size spectrum models, Osmos, Atlantis, CMICE, stock synthesis. These are data-hungry models. Needs a lot of data in different levels. So I'm not going into the details of EcoPath and EcoSim and all. This is the forerunner as far as ecosystem-based model is concerned, EcoPath and EcoPath. And another set of model is size spectrum models. Again, it considers the growth, reproduction, and mortality. So you can see, according to the body mass, the sampling is done, and we come out with the biomass estimates. Another set of models nowadays very used in many waters is stock synthesis. It's an integrated approach combining different kinds of data. Again, Atlantis, that's also biophysical, economic, social. Many parameters are considered in this particular model. This is another Osmos. Herein, what happens is it looks into even the primary producers, primary, secondary level producers. Everything is being taken into account in this Osmos model. This is CMICE. Again, when we talk about the models, if there are intermediary model is CMIS is an intermediate complex model. So we have talked a lot of about the stock assessment, but the base of a good stock assessment is the high quality data set. And even when we talk about single species models, though it is a data limited, but when data limited, it has got its own limitations. So complex multi-species models, it requires extensive and costly data collection, which is not affordable to many countries. But many developed nations are building their own complex multi-species models to manage their resources. So it has got its own advantage, as we know, it gives us more richer insights. So Andaman and Nicobar, I think now when you look into, the volume of or the intensity of data which requires, but maybe after 5 years, whether we may be able to build our own ecosystem model for the island, that should be the aim. So that we must have different data collection in different aspects like socio-ecological, socio-economics, ecological data, even fishing related data, environment data. If everything is in place, maybe after 3 years or 2 years or 4 years, the island can come out with its own ecosystem based model. So again, when we translate the stock assessment model outputs, ultimately we are looking into the fisheries management that should lead to a science-based catch limit, size limits, fishing gear restrictions, and seasonal closures. So that is the direct application how we can that we get from the stock assessment model. So ultimately, to inform the management, we need a shared responsibility. That is what I believe. It's an investment in healthy oceans that must or should lead to thriving communities and a sustainable future for all who depend on the sea. So let us prioritize quality information for a prosperous and sustainable fisheries sector. This is actually 2 slides which has been shared by Dr. Johnson, who is working in seaweed farming. Actually, he has, because this may be an application. I know that department is doing many projects and schemes for the fishermen community. So this is an option that has been shared by Dr. Johnson. He is an expert in seaweed farming. These are something which you can look into. Another one is on the INTA, adoption of INTA. Shrimp farming, again, I think I have seen success stories in your waters about the shrimp farming and all. So I think department can look into seaweed and INTA so that it can be lucrative livelihood options for the community. That's it. So let us unite for sustainable fisheries. As quoted, let your hook always be cast. Some fish will will eat the bait and let it come your way. Let us hope for that and let fish be forever. Thank you. Thank you for hearing me.
Thank you, madam. Thank you, madam, for the comprehensive presentation on data collection, quality of data, its interpretation and modeling. Am I audible?
Yeah.
Yes. In the screen, we have a QR code given. If anybody from the participants have queries regarding this presentation or regarding this session, they can scan the QR code and ask the queries now. Anybody
So
from
till the time questions are coming, can you ask your question?
Okay, thank you, madam. Thank you. Actually, this project, as you know, madam, we are it is our third year of project now. And what we are facing in this project and this data collection project is the total data collected is getting underreported because we have because we have last year data we have around our manual methodology we are adopting, and we are getting data of around 46,000 metric ton. And but as per our collection data collection system, due to various reasons, we got a production of around 18,000 metric ton. I think I'm correct. And that was our first year trial run. And major issue is, as you know, madam, we are very scattered actually from Diglipur to Campbell Bay. We are very scattered. So this scattering is making a problem to get the data on time, and our data enumerators are also changing continuously, and this mobile version of data is also we cannot use it like it is like one enumerator is coming and using for some time in his mobile phone, and again to log in different phone we are facing some difficulties. These are all the basic difficulties, and my doubt regarding this is we are following the potential Andaman Nicobar fisheries potential data, which is published by FSI during 2005. That is very old, madam, actually. Whether there is any possibility, without conducting such surveys, whether any possibilities to extract this potential from our data, from our collected data, the potential, whether we can take out the potential of Andaman Nicobar Islands, because since it is a very old data. And another doubt is regarding stock assessment, madam. Stock assessment, especially we have groupers, snappers, emperors, and trevally which are exploiting more than the MSY and all, because there is exploitation is more because of the demand also, and there is no such stock assessment studies for such species. Whether this data collection methodology can be used and adopted for assessing these stocks. And the last one is regarding, madam, minimum legal size. So minimum legal size, I know CMFRI has listed some minimum legal size of for some commercial species. Whether it can be directly adopted by the Andaman Nicobar administration, or we have to conduct a separate study for fixing the minimum legal size of the resources of Andaman Nicobar waters, madam. These are the basic things we have to, basic things from department side.
Yeah, regarding the first question on potential yield estimates, I think potential yield estimation, we must have a time series data, so that a long years of time series data is the basic requirement for potential yield estimation. So if the government is, I think the department is also already having your whatever method you have adopted earlier, that can be made use of to come out with an estimate for the potential leak. That is what, because we have started the collection recently, so we may not be able to, we are not having a long series. So that is one option. And the second one is the practical difficulties which you have. Practical, that is everywhere, even we in mainland as well. So practical difficulties has to be taken in another way. But theoretically, scientifically, what I want to convey with you all are how, because initially we got some results, how we can modify or how we can evolve to a sampling design which is exclusively implemented in islands. That should be the aim, should be, because you know better than how can you can change your sampling scheme, like how to change your sampling frame, how to change your stratification, how we can give more coverage to different centers, and how to improve our estimate. So these things, each and every aspect has to be learned, and that has to be incorporated in the existing sampling scheme, and it should be revised so that it should be suitable for exclusively for you. That is my opinion about the second one. And third one is just forgot about the third question. That is a minimum legal size. Minimum legal size, I think you must come out with, you should have study your biological data, then only the other one should not be used. That is my opinion on that. Exclusive study should be taken out in the Andaman catch data or the species. Then you should come out with a minimum legal size.
Okay. Thank you, madam. Thank you. Thank you so much. Sir, if there is, I think there is no other questions from audience side, from the participant sides, then we can conclude the session, sir.
So,
Sir, we can conclude, sir. Henry, sir, are you audible?
Yeah, please.
Yes,
Yeah.
sir.
Thank you, madam. Thank you for your time, madam. Actually, I think all of our technical staff attended this program, and it will be useful for their day-to-day data collection activities. Once again, thanks from the side of Department of Fisheries, Andaman Nicobar Administration, to the ICAR-CMFRI for giving resource support during this learning week, and thanks to Karmayogi ICAR portal for keeping this session for Department of Fisheries. Thank you all. Thank you.
I do thank the department for giving me the opportunity and the support given by the Karmayogi team. Special mention of Mr. Henry. Thank you so much.
Thank you, ma'am. Thank you so much. Nice having
Thank you,
you.
ma'am.
Thank you.